Hello dear friends. In this video, we will see how to delete a node from linear queue, or rather a queue. In the previous videos, we saw what is a queue, how queue can be built using a linked list, and how do you write insert function to insert a new node in the linked list, or rather a queue. So in this queue, you can see that I have drawn here, there are 4 nodes in this queue, 10, 20, 30, 40. 10 being the frontmost. So the front pointer is pointing to that node, and 40 being the rearmost or last node. So rear pointer is pointing to the last node. Now we are interested in deleting a node from this queue. Obviously, you know that queue is first in, first out. So if you want to delete a node, the only node that can be deleted or that should be deleted is 10. Now think of the changes before you read these delete function. I mean, it's so simple after learning stack using linked list and after learning linked list programs in the past videos. Just tell me if you want to delete this node. Shouldn't this 20 become the front? So what is the change necessary is that this front pointer, which is pointing to 10, should not point to 10. It should discontinue to point to 10, but it should point to 20. Isn't it so? And any other change needed? Absolutely no other change needed. That's it. That's it. By asking front not to point to 10, but to point to 20, you notice now that this queue is going to begin from wherever the front points, and front points to 20. So the queue begins with 20, and 20 has a follower 30, and 30 has a follower 40, and 40 has no follower. It has next equal to null. So deleting a node from the queue, that is frontmost node from the queue, is only advancing the front pointer using the next pointer of the first node. You can observe that the next pointer of the first node, that is next of 10, is pointing to 20. So you can ask front not to point to 10 but to point wherever this next pointer is pointing, isn't it? So what is the plan? How are we going to delete this? You might have already read or gone through the code written on the left. For the delete function, let's see the code in detail now. The delete function again gets address of the queue. So P is a pointer which points to queue, and now we will handle the queue using the pointer. So we will write notations like P arrow front and P arrow rear. In this particular function, we have declared two local variables. X is simple integer and temp is a pointer. As you see, temp is a temporary pointer of node type. That means in the memory there is a pointer called temp now. It's not pointing anywhere because we have not asked it to point to any node. But later temp can point to any node. And x is simply an integer variable. Now the next line asks temp, you should point wherever P arrow front is pointing. Just check. Temp should point wherever P arrow front is pointing. And P arrow front is pointing at 10. So obviously temp should point wherever P arrow front is pointing. So temp should point to 10. You will ultimately understand what's the use of this temp. Just wait for 2 more lines. Now what? Obviously we want to delete this 10, isn't it? Or rather this node, because it is frontmost. So what we will do is we'll ask x, check this line I am underlining. X is an integer variable to store data at that node. So P arrow front arrow data is 10. So x, which is another local variable, stores the value 10 so that we can return this value back to main. Now comes the big point. Just check this line. P arrow front should change. We have written P arrow front equal to. So P arrow front should become equal to P arrow front arrow next. What that means is wherever P arrow front arrow next is pointing, observe that this next is pointing to 20, isn't it? This right hand side, P arrow front arrow next is pointing at 20. That means P arrow front should also point to 20. Here is the change now. This P arrow front, which was pointing at 10, will no more point to 10. That's very important change, isn't it? Now P arrow front will point to 20. By the way, you just observe now the queue starts from 20 because wherever front points, the queue starts from there. So this 10, the node which stores 10 is as good as deleted. It's delete function that we are learning. 10 is there in the memory, I agree. I mean, we have not erased 10 or we have not returned this. We have not announced it to the operating system that we don't want this place anymore. But although it is there in the memory, this node is there in the memory, it's of no use because it's logically not in the queue because the queue now starts from wherever the front points. But then we can actually physically remove this by calling a library function free, which is just opposite of malloc. Recall, malloc is meant for allocating the space for a node and free is meant for returning that node back to operating system or returning the memory occupied by that node to operating system. And grammar for free is so easy. I mean, we have seen this in past. There was a separate video on malloc and free where this was explained in big detail. But just to recall a few fundamental facts, free temp means free the memory to which temp points. And observe temp points exactly to this node. So what's going to happen, you can think of this, that wherever temp points, this space, this memory is going to be released. It's going to be returned to the operating system. And now you watch that really the queue starts from 20 and goes up to 40. So that's how you delete a node. Last statement is return x. Watch the delete function. Last statement is return x, where obviously this 10 is returned back to main. So in summary, what you can know about delete? What is delete function? Delete the frontmost, obviously. Adjust the front pointer so that it points to the next node, obviously. And then release that node which you have just now deleted by using free. I hope you have understood why we have used temp. Coming back to the question, why did we use temp? First, what we did was we asked this temporary pointer to stay here, wherever front points. And then we said front, you can now change. You can now point to 30. So we have this front pointer not pointing to 20, but it is pointing to 30. But don't worry, we still have a pointer pointing at 20, which is temporary pointer. And we can now use free temp, free the pointer. That means free the memory to which temp points. And so comfortably now we can return this memory back to operating system. And just check now the queue starts at 30. So that's it. That is how you delete a node from a queue. Of course, the empty function is written just as we wrote in stack using arrays and stack using linked list, which will inspect whether there is anything to delete or not. The queue is set to be empty if front is null. Just observe if we have a queue in which front pointer is null. Of course, I know there is a rear pointer, but just talk about front right now. Somebody says that front is not pointing to any node. Front is not pointing to any node. Front is null. If front itself is null, it means there is nobody standing in the front of the queue. That means the queue is empty. So if front is null, if this is true, we are going to return 1, and 1 means true, as you know. Otherwise, we are going to return 0, and 0 means false, as you know. So how are you going to call this delete and empty from main? Just as we saw in the earlier videos of stack. Here is case 2. You know, in this menu driven program of main, in the menu driven program, second option is for delete. And if the user enters the choice as 2, then we are into this case where we will first check if queue is empty. Just in English, if empty and queue, if this is true, then there is no sense in going to else, isn't it? Because the queue is empty, you can't delete. There's nothing to delete. So you announce queue underflow and don't go to else. Whereas if the queue is not empty, that means this if is false. Empty queue is false, that means queue is not empty. Then you will land up in else and you will call delete function, which will return the value. Recall how it returns 10, 20, whatever value it had deleted. And then using simple printf, you print the data, that is z, that was deleted. That's how we are calling the delete function from main. In the next video, we will see how to display all the elements of the queue. Thank you very much.